In 6th grade, we take our knowledge of positive and negative numbers and use it to locate points on the coordinate plane. This plane is essentially two number lines, one horizontal, one vertical, that cross, creating a space for every rational number. We use ordered pairs, written as x, y, to give every single point a unique address. Our job is to understand how these four quadrants work and use them to solve problems, especially involving distance. Let's review the structure of the coordinate plane. The x-axis is the horizontal number line, and the y-axis is the vertical number line. They cross right in the middle at the origin, which has the address 0, 0. The key is to remember the direction. Positive x goes right, negative x goes left, positive y goes up, and negative y goes down. The axes split the plane into four sections called quadrants. Quadrant 1 is the top right, where both x and y are positive. Quadrant 2 is top left, where x is negative and y is positive. Quadrant 3 is the bottom left, where both x and y are negative. And finally, quadrant 4 is bottom right, where x is positive and y is negative. Always remember this sign pattern. It tells you exactly where a point belongs. An ordered pair, x, y, tells you exactly how to get from the origin to your point. The x-coordinate is always first, telling you to move horizontally, either left or right. The y-coordinate is always second, telling you to move vertically, either up or down. You must always start at the origin and move horizontally before moving vertically to correctly plot your point. Since we are working with rational numbers, the coordinates don't have to be whole numbers. They can be decimals or fractions. For example, to plot the point 1.5, -2, you start at the origin. You move right 1.5 units on the x-axis, and then you move down 2 units parallel to the y-axis. That puts your point right in quadrant 4. Let's plot a mixed number in example 1, -½ and 2½ The x-coordinate tells us to go left 1/2 unit from the origin. The y-coordinate tells us to go up 2½ units. We end up in quadrant 2. This is a great example of how rational numbers have precise locations on the grid. If either coordinate is 0, your point does not fall into a quadrant. It lies right on an axis. The point 3, 0 is on the x-axis because there is no vertical movement. The point 0, -4 is on the y-axis because there is no horizontal movement. Remember, the axes themselves are the boundaries of the quadrants. One of the most important things we do with the coordinate plane is find the distance between two points. We can only do this directly if the points are on the same vertical line, share an x-coordinate, or the same horizontal line, share a y-coordinate. The distance is found by taking the absolute value of the difference between the two non-shared coordinates. In example 2, we find the horizontal distance between 3, 4 and -2, 4. Since the y-coordinates are the same, we only look at the x-coordinates, 3 and -2. The distance is the absolute value of 3 minus -2, which is the absolute value of 3 plus 2, which equals 5 units. In example 3, we find the vertical distance between -1, 1 and -1, -3. Since the x-coordinates are the same, we look at the y-coordinates, 1 and -3. The distance is the absolute value of 1 minus -3, which is the absolute value of 1 plus 3, which equals 4 units. When finding the distance between points that cross an axis, like moving from quadrant 1 to quadrant 2, you can simplify the calculation. You just add the absolute values of the coordinates that are changing. This makes sense. You're measuring the distance from the first point to the axis and then adding the distance from the axis to the second point. Let's find the distance across the y-axis in example 4 between -5, 2, and 3, 2. The horizontal distance from -5 to 0 is the absolute value of -5, which is 5. The distance from 0 to 3 is the absolute value of 3, which is 3. Adding the two absolute distances, 5 plus 3 equals 8 units. The coordinate plane is also great for understanding reflections. When you reflect a point over the x-axis, you just change the sign of the y-coordinate. The x-coordinate stays the same. When you reflect a point over the y-axis, you just change the sign of the x-coordinate. It's like folding the paper along the axis. In example 5, we reflect the point 4, -1 over the x-axis. We keep the x-coordinate, 4, and change the sign of the y-coordinate. -1 becomes +1. The new point is 4, 1. The point moved from quadrant 4 to quadrant 1, a perfect mirror image across the x-axis. In example 6, we reflect the point -2, 3 over the y-axis. We keep the y-coordinate, 3, and change the sign of the x-coordinate. -2 becomes +2. The new point is 2, 3. The point moved from quadrant 2 to quadrant 1, a mirror image across the y-axis. The coordinate plane is an essential tool for solving geometry problems, like finding the area of a shape. If you have the vertices or corner points of a rectangle, you can use the distance formula to find the length and width of the sides. Once you have the length and width, you simply multiply them to find the area. Example 7 gives us the vertices of a rectangle. The horizontal side runs from x-coordinate 2 to x-coordinate -4. The length is 2 plus 4 equals 6 units. The vertical side runs from y-coordinate 3 to y-coordinate -1. The width is 3 plus 1 equals 4 units. The area is 6 times 4, which is 24 square units. In real-world applications, we use the coordinate plane to create maps. The origin can represent a key landmark, and other points can represent different locations, like fire hydrants, buried treasure, or in this case, submerged buoys. Plotting these locations allows us to calculate how far apart they are, or their direction relative to the center. Example 8 is a simple contextual distance problem. A robot starts at 1, 0 and moves to -1.5, 0. Since the robot is traveling along the x-axis, we just find the horizontal distance. The distance from 1 to 0 is 1, and the distance from 0 to -1.5 is 1.5. Adding those distances, the robot traveled 2.5 units. For your final challenge, consider the points A at 0.5, 2, and B at 0.5, -1. First, find the distance between A and B. Then, if point B is reflected over the y-axis, what would the new coordinates be? This wraps up all the key skills: plotting rational numbers, finding distance, and performing a reflection.